electric charge. We're going to now start looking at the electric field that we have around when two objects are attracted or repelling each other. So this is looking at Coulomb's law, and Coulomb's law states that an electric force is exerted between two charged particles. The closer together the charged particles are, the greater the force is going to be exerted. And so we have this equation that is related to this. We have electric force, F, is equal to the Coulomb's constant, 9 times 10 to the 9th power, multiplied by the charges, charge 1, charge 2, and all of this is divided by the distance between the two charges squared. So this is how we can calculate the electric field felt between all the charged particles. And we're looking at just, again, two charged particles together. So I have a sample question that we're going to be looking at. And today's question is looking at between two particles in an atom, between an electron and a proton. I want to find out what the electric field is if I know the distance between these two charged particles is 5.3 times 10 to the negative 11 meters. So let's look at how we can apply this equation to our problem here. So our sample problem reads, again, it's the distance between the two an electron and a proton, and we want to know what the electric force is around these two particles. And so if we go back to our guess method that we've been implementing here in the recent days, I'm going to go ahead and put my guess up here so we can look. Okay, now let's look at all the given information that we have. Well, we're talking about two charged particles. We're talking about an electron and a proton. So let's look at the values that would be implemented. An electron, the Q for an electron is 1.6 times 10 to the 19th coulombs. Now the charge for a proton is positive 1.6 times 10 to the 19th coulombs. And then we have, negatives. These are both negatives. Negative 19, negative 19. And given information, we have the distance between the two of these particles is 5.3 times 10 to the negative 11 meters. And of course, we know our K constant, a Coulomb's constant of 9.00 times 10 to the 9th power. And we do know that this is a constant that is felt no matter what charge size we're looking at. Now, what is our unknown variable here? Well, our unknown in this case is going to be, we want the force, the electric force. I'm going to move these over a little since we ran out of space. So here we have our unknown is F electric. We want to know what the force is that is applied between these two particles. Again, because Coulomb's law states that the closer the particles are together, the stronger the force is going to be. So the equation, again, is this one that we wrote up here. So it's Fe is equal to K coulombs Q1 times Q2 divided by R squared. Now I can either put the little dot for the multiplication point, or I can put parentheses the way I did on top. It doesn't matter. In either case, we know that that means multiplication. So now let's substitute all our numbers here that I have for my equation. The force is what I don't know, so I'm going to continue writing Fe is equal to my values. Now let's substitute. I have a value for K, that is my constant, 9.00 times 10 to the 9th power. Then we have our two Q's. Q1, we'll say, is the electron one. So the electron value, negative 1.60 times 10 to the negative 19. And the other Q, which is my proton, that would be my Q2 in this case, is positive 1.6 times 10 to the negative 19. And all of this is divided by the distance between the two particles, or the proton and the electron, which is 5.3 times 10 to the negative 11. And not this number is squared. You cannot forget that you have to square the value. So if I do the math correctly and I multiply 9 times 10 to the 9 times negative 1.6 times 10 to the 19th times 1.6 times 10 to the negative 19 divided by 5.3 times 10 to the negative 11 squared, my force electric between a proton and an electron comes out to be 8.2 times 10 to the negative 8. And again, because we're talking about force, our unit would be newtons. And that is our answer. This is our final answer to our problem. So it's a basic equation. All we need to know is obviously the charges involved. We need the quantity of the charges involved. We need to know the distance between these two particles, and our Coulomb's constant is always the same value, 9 times 10 to the 9th Newton meter squared divided by Coulomb squared, which is the same value we looked at, or we were going to use when we were looking for the force that the field exerted at a certain distance when we were just wanting to know with one particle. But now we're in between two particles and we want to know what this force is going to be. Whether it's an attractive force because both of them are opposites, or it's a repelling force because both of them are similars in charge, it doesn't matter. We can calculate the field it is. So in our equation, in this case, we have a negative with a positive, and the attractive force at the end is negative. But at the end, it does not affect our overall value because this negative is only indicating in what direction the force is towards. And obviously, it's towards the negative electron because everything moves towards the negatives. Remember that we had the field lines, the negative had all the arrows coming in. If it was a positive number at the end, it would be pulling away. These are opposites, proton and electron, and so they're attracted to each other, and all the force is affecting more towards the electron than anything else.